Good afternoon, everyone. Welcome to the day 6 of our ATAL FDP program. Today, we are having Mr. P. Radhakrishna Murthy garu to enlighten us on the topic Sustainable Energy in IT Infrastructures. Sir is Principal Technical Officer, IT Division, CSIR-CCMB. Also, MTech Digital Systems from OU Campus, CCMB, working as in charge of IT division CCMB from 1989, taken care of SCADA systems for environment monitoring of 80 deep freezers, walk-in freezers, and BMS systems for biosafety labs like BSL systems, conducted workshops, guest lectures in OU campus, Department of Mathematics, JNTU faculty development programs also. We welcome you, sir. I would like to request you to take over the session from now.
Yeah. Thank you, Anusha, and thank you, Asanda. And good afternoon, everyone. So, inviting me and making myself to share my knowledge. As Anusha has told, I am basically a technical engineer, taking care of CCMB as a research lab. And it's one of the very popular lab in biology. Most CSIR, we have around 43 labs. Amongst one of the top leading lab in the biology is the Center for Cellular and Molecular Biology, which you are seeing the activity that is the gate. It is located at Afsigoda. So the vision of the construction of this bio labs or any research labs, I think today in COVID, you might be finding a lot of difficulties and encountered, which these research labs are really useful, made us more successful to develop a vaccine. So I feel great CCMB also participated in that and made us very successful. So now, when you talk about these research labs, the environment is also very important to be sustainable and make it to be useful for the labs, for the society. This is more important. So our founder director, Dr. Bhargava, has a vision how to construct this lab. Really wonderful. I'm talking about this building is constructed in 1987. So that I think you can visit CCMB as a teacher, or you can write to director and you can see how the facilities are there from 1987 to 2025. I joined in 1989 after completion of my engineering. Then I'm working there. And I'm lucky to, or I can say proud, how environment of CCMB can be actually from the scratch. I joined while constructing the building. Almost some part of the building is ready. Though there itself, I have taken my responsibility how we can make up this system. So when you talk about the research labs, okay, so just one minute. Yeah, this is one which I'll tell you. So these are the people who are Nobel laureates, different nations, the persons. These photographs are very oldest photographs. Dr. Lalji Singh is one of the man behind the DNA fingerprinting. Today, a lot of forensics crimes, and he is the man behind of that, Dr. Lalji Singh. So I always salute him. So these are. So now I'm one of the person there. I'm taking care of these visited professionals. Okay, what is the unique of CCMB? I'm explaining. Okay, sir. So hope everyone is okay audible. So I'm making into this system. So when you take really how the research labs, this is more important. So when you talk about the laboratories, they're all playing very important role, particularly science and technology. Our Prime Minister Modi also very much dedicating to the science and technologies. But what is the problem in these labs setup or labs usage? Okay, not very bad, but there are something. So what we should understand is, so we should also take care, our responsibility, that how it is going to impact on the environment. That is the very, very critical things which we have planned. That is the greatness of CCMB. So we have, of course, everyone will take, but we feel. So how you can, from small things like the usage of pipettes, the plastic covers which comes along with that too, how to save from energies. Think it of today, this workshop is going on. The vision of our what you call our directors in that time has been taken care. I'm talking about 87. Okay. So use it in the day-to-day lab operations and to avoid these climatic changes substantially and making more successful towards research and not to damage our environments. This is what the combination which has been taken care. So some of the things. So before entering into that, you must have, I think if you are already biological people, they know. But if you are non-biology, who are not having, so because of this is a teacher faculty program, so I want to bring notice to the teachers, lectures, sorry, whoever is there. So how the biological research lab, this is a Government of India lab, which is very, so before going into that, we are going to solve, these are the problems. Why sustain, how the sustainability of this one, we are going to known for resources intensive operations. I told you, easy, it's not easy to set up the lab. We brought we struggled to get the water for our lab, really thanks to that, the time Chief Minister, and planned separately and provided. And we have internally hazardous wastage system we have created and burned, not to throw, because we got some of the how to take care of radioactive materials. We use radioactive materials. We got something which is P32 material, which are being used. So this practices, that sustainable practice helps reduce this impact of environment. So providing more and more cleaner environment. That's more important for us. The second one, first one is establishing and maintaining the lab. The second important is maintenance of lab. Again, the problem comes, people will give you construct a lab, but again, the problem comes maintenance of the lab. This is more important for us. So how we can make that cost effectively, we can make that maintaining of the systems. Third one is, I think everybody knows well, we ourselves as a scientific community member, we have moral obligations to protect environment and gives to a good environment for the future generations. So that is what we have certain, okay. So ethical responsibilities. That's what we plan it. So then these are more likely to thrive in long term. Okay. So that's a long-term viability also we have taken. Now you can see this. This is the basic clean room of our systems. Our lab has got this facilities. Like, what are the main motto? My responsibility is how these equipments, okay, so how these environment efficiency we are going to take care. This is more important for us. Okay, sir. So now I think you might have heard about what is the different types of energies. This is more important because we will all required very high-end electrical power for these labs. So most important for us is how to minimize our energies usage, power energy, which are very important for us, very critical parameter. Our director always feels worry about what is this month current bill. Okay, this is very budget in the budgets allocation is because we have a centralized air condition. Okay, not only and all the instruments like incubators. I think we all knows well, in our house we have only one freezer, one refrigerator. If you ask to buy second refrigerator, immediately my wife will say, why you want to go for second refrigerator? Enough, because the operation, the cost, that is main important for us. So similarly, we have thousands of, I think you can see there are deep freezers. Okay, minus 80 degrees freezer, minus 20 degrees freezers, cold rooms, refrigerators. Okay, these are all what you call why these are required in a biology lab. Why so many are required? If you visit, you find so many, because we want to store the samples. Like we get a samples, blood samples from Andaman. People have visited, scientists have visited our DNA labs. Very old ancient DNA samples are brought from collected entire world or something like different places. Okay, so these DNA samples storage is very important for us, very critical for us. Okay, so when talk about storage, they're all stored in very cold environment, like minus 80 degrees freezers, minus 20 degrees freezers. So we have n number of units. Actually, we got 4 floors, and you can think it of each, again, we have got 3 wings. Okay, and each wing we have around 15 to 20 minus deep freezers. 80 will have around 4 to 5. Such a vast number of units we have here. So now the question comes, how to save energy? Okay. So now you think it of what way I can save energy. Vasundhara ma'am, are you there in that? Hello, Pratyusha?
Yeah, sir.
Vasundhara ma'am is there?
I don't know, sir. Like,
okay, okay, no problem. I'll say. So now the question comes, how to save these things? How to energy can be saved? So the most important thing for us is what our directors all, what we thought is, okay, I'll tell you one example. Like you have AC in your house. Okay. Now you switch on your AC. What is the problem with air conditioning? You switch on 24 hours, so you work, make it to on, and something is failed in that. This is more important for us. See, suddenly, for example, the compressor has got some problem. Okay, the air conditioning is not working. You are there in our house, you are in the bedroom, and immediately found, or your wife will say, our children will say, Daddy is not getting cooled. Then immediately we'll check, we'll see that. So we take the action immediately. We'll see that something is not working. We'll switch off that AC. What is the advantage of that AC switch off? The real advantage is we are saving on one, damage of unit. We are avoiding the damage of unit. The second one, we are energy we are saving. Imagine you are went out of station and you forget to switch off your AC. Okay, you assume you have 4 to 5 ACs in your house and all are on, and something is which is not working, and it is a continuous, because if people think something is okay, we'll no, but our responsibility. That's why this more important is how to minimize. This is more important for us, the wastage. Okay, that is what we have to see. We are thinking of alternate resources. That's very good. But at the same time, in our hands, we should see that how to improve the utilization efficiency. This is more important for us. That's why in our house, old people or elder people, sorry, I cannot say, elder people, mother and father have said, or we have become elders. And when you forget to switch off the light and fan, and sun comes out of the room, immediately we'll say that, switch off karke aa jao. You get angry. Why you get angry? Again, going back there. This is the biggest problem. Again, going back there and switching off is a big issue for them. So that is what we have to teach them. That is very, very important for us. Okay. If you make in our house discipline, if you give, automatically the discipline comes through his life. And which organization he works, he will take care. And entire society will give a good part of that. So that's what I'll tell you always. So for our sustainability of energy is very important for us is, my view, organizational view, increase the efficiency of usage and minimize that. Okay, power usage, and not only power, anything, any resources, I can say. So this is more important point for us to keep it in our minds. So how it is possible? That is what we are looking here. So now think it of how it is possible, how you are switched off in your home. You have switched off your home, that AC is not functioning because you are there. Your presence is there. Since your presence is there, you are immediately understand something wrong and you are. But these deep freezers, these freezers, 24 hours, 24/7 on, and in the lab, the scientist will leave, students will leave at a particular time. And if something goes wrong, okay, we need the identity. We need emergency care. People think emergency care for humans. Not only that, I will always, as an engineer, I think always the emergency care. Because why emergency care? There are two issues. One, the samples goes bad. The second, I think I need not tell any time. So it's a energy saving. Don't waste energy if it is not required. This is more important. We have 200, 300 units. If they are running 24/7, and if you don't identify them properly, which are working and which are not working, you are going to cost more. So for this reason, okay, what we can do it, this is more important. So we have created, very important for us is how to monitor these units, okay, how efficiently they are working. This is what we have created, one unique facility, which we call central monitoring system. So you can see there, really great our vision of our founder directors and other members who have given a thought of doing this one. This is 24 hours manned by single person, which is at the cost of saving of energies, resources, all this one. That's what in 80s I'm explaining how this system works, how this system is designed. So this entire lab is distributed, all these equipments in different locations. So our responsibility is how to interconnect. That time no LAN, okay, no internet, but still we created environment for this particular management of a system, which we call it as a CMS system, central monitoring system. So now how it works, that is what we should know. I think if you see there, how we have given this one. So this is the one which we have designed and installed. Okay. So now today, I think this has been acquired in the various places, okay, which has come nowadays, all the central AC units, which people are using it, which is called as a building management system, BMS. But this is a different, which unique system, we design with the help of CMC computer systems. We have made a particular system, how it is being useful for us, customized for us, and made it to work well. And we are very successful in that one. You can think it of how much power is being used for us. Okay, so you can see there. Now, not only temperatures, we are having a compressors, what you call pressors, and we have chiller units. All this of another important for us is when this air comes, very important. Most of the people, particularly, should take care of this one. Why not? You think all you see, if you don't clean your car AC filter, what happens? Very simple. The air comes, flow velocity of air coming through that filter is become less. Again, problem. Our children will say, "Arey, hava barabar nahi yaar." Then immediately what we will do? We increase the speed. Again, you are wasting. You don't know. You feel it, then people will be happy. But that is not a real source. The real problem is you should identify why. When you are having regular checkup, what is the reason? So that's why we are feeling. That's what you can see there. You have air filters. Actually, they're all micron level filters, 0.5, okay, 5 micron. These are all which very commonly we use in our system. Okay, so that's why very important for us is in day-to-day operation, day-to-day 24 hours by 7 monitoring of our units made is more successful and makes us more efficient and have a unique system. And it has been taken by so many people who are wanted to have such a system, particularly biosafety labs, biology labs, which is required this much very useful. Okay. So how it is being designed? So because I want to see here, I want to have some talk on this one because I know how to make that. So now you tell me, today people are thinking about energies, environment. What is the biggest problem in that is environment is a physical system. Now the problem is what? You are going to alarm with the help of electronic system. This is see the difference. Which I am talking related to this. Okay. So now you tell me, where is the problem exist? Really, how to convert problem arises. There the problem is going to come. I understand. This is a real SCADA system. Okay, data acquisition system. So the conversion process, how we have done, how you have measured temperature, how you have measured pressure. Okay, I'm talking about these things. So that people can have understand. Okay, think it of, you only think it of what is the engineering behind. First engineering is what is required. Okay, these physical parameters. The most important point of here attraction is, I think you all knows well, sensors. Understand? Sensors are made, designed, practically possible, practically feasible. Understand? So really great of that scientists and engineers who made that sensors are today, we are able to save our energy systems. What is the difference between old refrigerator and today refrigerators? Auto defrost. How auto defrost is going on? Because they implemented, practically standards are improved. It is very really great of that. The people who are manufacturing these refrigerators with the latest technology, embedded with electronic technology, and making the systems to work more useful. Really great. So now you tell me, here also finding the sensors. So the first parameter or first design criteria is how to select a sensor. There it starts the problem. Understand? So for that, we are having the, particularly you can see there, this is the, understand? I'm going to talk, these are various sensors, okay, which we called RTD, resistant thermal devices. The second one is thermocouples. Okay, all your freezers, refrigerators will have these thermocouples. Similarly, I think you all knows well, we have our computer or mobile. I think you might be had it. If some type of temperature increases because of charging or because of failure of batteries or something happening, immediately that has to be censored and stop the power. That's what the thermistors are going to do that one. Similarly, we have the semiconductor, okay, or temperature sensors, which actually these we call it as, this is the basic, if you see this is the probe, this is the one. Understand? So this is the one which we are going to insert into the system and make you that PT100 probes. Okay, so temperature probes. I give an example of only for, I'm not going in depth what is the other temperature probes or pressure probes which you are going to see that. But basic, see, basic my today's lecture is give the knowledge of how environment monitoring will be done. That's all. This is the way how I want to talk, but practically I'm taking my example, my lab example, which we are using among all this. Okay, so we mostly use these two. One is RTD probes. Mostly I use this one, and these are all also inbuilt to some of the instruments. They have this one. Okay, so this see the main success is the design of this probe. Now you only tell me the sensors are playing very critical role. Today you are monitoring. See, human being has got a very good sensitivity of body. Yes or no? Suddenly you feel some cold air is coming, immediately your brain thinks, I'm getting a nice breeze. Yeah. Similarly, when you see a beautiful colors or beautiful flowers, immediately your mind will get happy. How nice. How? Yeah. These are all sensors. We have an eye sensor. Okay. We have the skin sensors. Very good. If you touch a heart, immediately our brain tells, hey, don't touch it. Because these are all, our entire body has got sensors. What are the other sensors we have? Very simple. We have the ear sensor. Any more? What is the other sensor is? I think very important is nose. Understand? Nose is a sensor. Really God has created for us. We have a different types of sensors inbuilt to body for us. Now we are, you know what is happening? What is the now biggest problem is we don't have artificial nose. Understand? So, of course, cameras are there. You can see vision. Right? Tomorrow, artificial nose comes. What happens? You think it of what is the advantage you'll have? Anyone can tell? Today, my daughter and son is at the USA. And when mummy makes nice biryani, when he makes in house biryani, what is the advantage? What is the you feel? Immediately feel angry only because of nose. They sense the aroma of that biryani smell. You feel great. Understand? And you feel you eat more because of that smell. Understand? I think some vegetarian, some people, sambar, another big example, you can feel nose. Now you tell me, that type of sensors are more still should come. So when you give a robot or AI, ask that, what is this one? It able to tell, no, sir, it is a sambar. That's a very common. I think it's going to come. No, you should tell it should be done by so-and-so chef, so-and-so cook. That because, you know, the distinguish is there. Why your food is made by mummy and wife? What is the difference? You all, because you born with mummy, you feel, how much good mummy, wife generally don't feel bad, we are the wives, but generally feel it. Kya hai, mera mummy ki taraf tumne nahi banaya. How? Because we have tongue taste. And these are, because these are all very important. If really those are also comes in artificially more successful, we'll see how the environment or whatever. Really that way, I feel sometimes, I also feel sometimes required. How to transmit? If really we have a sensor to acquire this sambar in electronic format, I can send to my children who are in USA. So they need not to come to India. They feel it, ye mummy ka banaya, so I will be happy to see this taste of sambar. That's what we wanted. What else do you feel? Other one? I'll tell you one more sensor, which is very important for us is touch. This is the biggest thing. Human has got a very positive feeling. How touch feeling you have? Yes. You see, somebody touches you immediately, you'll see, Are kya Mota fellow, you only touched me. Okay, somebody closes your eye. Are what? No, all these are not. Main important for us is the child bond child. The bond child first recognizes mother's touch. Understand? That's why doctor once he put it, this mother's touch is more important for us. So once they see, our brain senses who touched it. Really great. So now you tell me, all mothers nowadays, because of society is like that, all working women is became. 6 months, when my daughter is saying, and today I'm facing sometimes bad. Is it required so much? Left 6 months maybe in the house or child care, and going there, and if the child care person has called back, sir, she's not stopping crying. Then my daughter come back, and nothing she has done. She touched the baby. That's all. She stopped crying. See that? Imagine. So we want, still research is required. Why I'm talking is, where the space is there for research. In a future generation can fill this gap is more important. Today, temperature sensors, pressure sensors, these are all available for us. Understand? So, but we required more and more how you can have these sensors. So I always feel great. Thanks to scientists, engineers who involved in this. If you don't have sensor, no environment monitoring, and environment becomes more bad. So that's why I will always thank, because my life also, I got a job because of it. I feel great because if there is no sensor, no post of that, and I could not have got my job also. Okay, I did my electronics, okay, industrial engineering that time. Anyway, now you got a sensor, electronic. Very important is, what is the electronics will do? Nothing. Electronics is flow of electrons. Okay. Simply it gives a current by changing resistance. Other than nothing, it, of course, don't think it's a lot of things, but basic principle I talk like that. But it is not sufficient. Why it is not sufficient? Now I want to have my proper data, that how I can translate. This is the biggest problem. Okay, what is the engineers or scientists behind this development of this environment monitoring is, I'm teaching fundamentals, sir. Who are knows well, but who don't know, really, these are the very fundamental concepts of environment monitoring of parameters. Okay, so one is sensors, right? Electronics. So that is one part. The second one, how I can convert that currents are mapped. See the words, which is very important for us. Really, thanks to the mathematics. I'm telling you, all mathematics teachers should be proud of this one. Why? Without maths, this is not possible at all, I'm telling you. Whatever people are thinking, AI, ML, all the behind of this, the mathematicians. So I give a big proud, because this seminar is also conducting by mathematics department. I really congratulate them taking this one. So what the mathematics involved in this? Very simple. I told you, my sensor is converted the temperature into current, but that current should be, again a word comes, 20 degrees C, 21 degrees C. How it is been mapped? Mapping. I think you all know well. What is the mapping? Mathematical teachers know well. Very simple is functions. Very great. Algebra is always very, very useful for us. Algebra, coordinate geometry, calculus. These are all the things. Today, automation has come because of these people. Without them, nothing is possible. I'm telling you. Automation. What is automation? Human interaction is less. I'll tell you, your AC in our house is monitored by you or your family. But whereas the ACs or freezer, whatever the equipments, 24 hours running in a laboratory institutes, this should be monitored with the help of automation only. That automation can come again. How these SCADA systems are designed. So there, the mathematics has come back. So now I will thank you. So for that, what is required here is that, excellent, just one minute. I have a small cough.
The recognition should come. That is the main part.
Rakhi sound was that favorite challenge.
Yeah. So now back to this. Sir, how you are going to have the, how this you are going to have this conversion into the physical parameters like temperature. Finally, end user wants, I'll say 4 milliamps. That fellow will shout, what this 4 milliamps? I don't understand. You tell me that into my physical parameters. So that has been done. Who is the response? Who is the man behind this one? Or what is the behind of this one? Is a great mathematical modeling. Understand? So mathematical modelings are very important role, this physical environment setups. Okay, not only here, but a lot of things. So I'm going to show you small example here, how it has been done. Is it visible or okay? I can, anyone can answer. Is it visible, sir? So
yes, sir.
Yes, sir. Is it visible?
Yes, sir.
Yeah, good. Thank you. Thank you for feedback. Now you tell me what I have done. I have selected a sensor, electronics, a small current comes. If you see there, I think you can see here, there are two readings are there. What is that one? 4 milliamps and 20 milliamps. And I have taken a small refrigeration example, 0 degrees and 15 degrees. Now, here the mass comes. Very interesting. What is the mass here comes? X coordinate and Y coordinate. Very interesting concept. See, I am going to create our final end is computer should be able to calculate and tell what is the real temperature value. That's all. Simple logic. But how I design, how I solve that problem, I'm going to explain here. That's all. So this taken, given to my programmer. He wrote in a program C++ front end, designed all this. See, these are all different stories. See, that also a lot of effort has been done. But the real algorithm is a mess. Understand? Front end designs, keeping the text boxes, indicating, printing all columns and rows. That's all. That's also very difficult. But the real behind this is the importance is conversion of these values. Now you see this one. So I have taken two values, 4 milliamps, 0 degrees C, 20 milliamps, 15 degrees C. Now what you might have understand? Very simple. There is a mapping between temperature and current. So 4 milliamps, if you see here, I have taken 0 degrees C. 20 milliamps, I have taken here 15 degrees C. Very simple. It is a linear relationship is there. It is a linear relationship. What is the linear relationship? I think you people knows well. When I increment it by 1, there are also some, of course, little analog values, little changes, but I can almost approximately take a linear line. I've taken a simple example. And now you tell me what is our aim is how to design the linear equation for this straight line. See, really great, sir. In the school, I never understand why graph sheet is given, lines are asked to draw. We are very happy. Take a scale because that math class will have a scale, rubber, all a compass box and enjoy with hitting the others and childhood. And drawing the cave with all this, oh, beautiful. We used to get a good marks in the graph. I never expected the graph will be useful today in my life. Really great of mathematics. My sir, where I studied 6th class and all, that time, I never asked the question that how this graph is really useful in the society. Today, that line, what is the more critical here? Tell me, how to calculate the linear equation. Very simple logic I used here. Understand? I mean, this is very critical. So what is the here I have taken 4 milliamps to 20 milliamps. Why you have to take 4 to 20? Okay, why not 0? This question also comes. If you take 0, the problem is very simple. If really that sensor is failed, 0 current comes. We don't know whether is it because of 0 current that is failed or it is a 0 degrees temperature. That's why we call it as offset values. So design a offset value. So here I have taken 4 milliamps is my starting point, x coordinate, and 0 degrees C, temperature is on Y scale. I have taken 0 and 1. Now you tell me what is our aim is simple, y equal to mx plus c equation we have to develop. Now if you see, I think how many people know, most of the people will be knowing here, y and x are called, I think you know so well, they are called variables. Mari, m and c are called, anyone? Parameters. This is more important. Why I am talking is, when you, tomorrow if you do research on this topic, on like this type, your mind should have two concepts. One, what are the parameters and what are the variables? This is more important. Parameters and variables. Here, what are the variables I have? My variables are current and the temperature. What are the parameters to fix this linear relationship? Is the m and c value. Okay. So how I calculated this m and c value? This is more important for me. So I have taken very simple. See, I have taken y equal to mxc formula. I think as a mathematics lecturer, you all will be knowing. What is my x value? X value I have taken 4. Okay. And what is the m value I have taken? This is y2 minus y1 by x2 minus x1. 15. Okay. I'm going to take this one because this is y2 and 0 is the my temperature actually is set to 15 degrees. The freezer is 0 to 15. My monitoring, freezer may go 25 degrees, but I'm not interested. After 15 degrees, if it's there, something I should take action. That's why the cutoff temperature is 15 and starting temperature is, okay, I've taken 0 to 15 degrees. So my values of Y value is what? 15 minus 0. And what is the current values which sensor my gives is 20 to 4. So I've taken X range is 20 and Y range is 40, 15 minus 0. Now I got the slope of my line, which I designed the M parameter. Thank you. Now everybody might have understood. Instead of decimals I wrote, you can understand 15 by 16. What is the another parameter I should calculate, sir? C value. So I'm teaching modeling, sir. Just remember this point. A simple modeling. Now you can write Python code for this. It works well. This is the basic model for practicing. That's why I'm concentrating on this one. So now if you see this, how to calculate C? Okay, so you know y equal to y1 equal to mx1 plus c or y2 equal to mx2 plus c. Already m is known. Either I can use y1 x1 or I can use x2 y2. Already I know m. So here I have taken x1 y1. Okay, so what is the y1? My initial value 0. I put 0. And slope I know. What is the x1 corresponding value? 4. Then I have taken c. I calculated. Now this, if you simply solve this equation, we are going to get minus 3.75. If you see this line, if I extend, so what is this meaning is, whenever there is no current in my sensor, the reading will give minus 3.75. It's a warning. Immediately people, hey, what is this? For temperature should be 0 degrees and something which is giving wrong. People take action. Okay, that's a different. Now, if you see this, again, I have taken our other calculation also. Understand? So if you take that other calculation, you can see here also y2 value and substituted. Again, current is 0. That is x equal to 0 and y equal. So now I calculated. Again, c equal to minus 3.75. So now I got both the parameters. C equal to minus 3.75 and m equal to 0.9375. Now, so total now I got a very simple equation, linear equation, y equal to 0.935 into x plus c. Okay. Hope everybody, simple mathematical linear model which we have given for us. Understand? I'm using it. See, and thanks to my math teacher, because making us to sense this type of environment created. And we are happy. This is working well. Same way I have taken for refrigerators, freezers, minus 25. Okay. And similarly, minus 70s. I changed my x and y values. My range, I changed it. Because for the other side, the current ranges are same. Anyway, this is how we have created. And thank you all. Okay, this is completed. So now you tell me, this is what we have done in 89. Okay, so now see here. So that is not enough today, society. Now you tell me, sir, what is the biggest problem? Okay, as the days are going on, automation has come, manual to automation has come, and computer has come automated. Really, electronics engineers are made automation. Sensors are generated, make you easy. Microprocessors are created to process prostly. Understand? Sensors, microprocessors, these are all one set of devices and made your life easy. That's why when you see olden days Chatak, later Chatak has come with electronic starters. Understand? I think how many people you remember? I used it. The advantage of electronic starter is given less consumption. Why less consumption? Because the starting of bike that time takes more power. So more petrol. Because of this electronic coil, which they designed and made it simple to operate and given less consumption. Anyway, thank you, sir. That is one which happened. Now you tell me, is it enough for the society? Still any people wanted more? Yes, it is more automation. It is not automation. Now we want more intelligence. See, really great. The second level today world is looking for that. Sir, I think how many people are using GPS? You are going with the help of GPS car. You are very happy. Of course, sometimes Google make you wife and husband going on, suddenly takes you into wrong direction. wife will carry driving. So these are all sometimes, that is not because of husband problem. It's all Google problem. Anyhow, that also we will feel sometimes enjoy because wife also calls, oh, nice, you're doing it. Okay. So, but GPS today made our life so simple. Now, what is required more in GPS? GPS works in sensors. Your car location, very simple. Satellite GPS measurement and the same equations. Over. I'll tell you, you're stuck with some accident. Think it of, you are alone. In the midnight, you are traveling. What is required? Nobody is there, no manual help. Okay, who can help you? You can't, you are almost in a fallen state. But you require some help there. Yes or no? Yes. Now what is that? We need a system. Which system? Google, I think, next implement this. What the Google, when you switch on this, when you make your GPS on, what happens? It keep on crying, keep on talks. Take right turn after 500 meters, keep right turn. You imagine exactly that whenever it is shouting, there only or you met an accident. What happens, you tell me? It's keep on shouting. Take right turn at 100 meters, keep right turn at 100 meters. Where 100 meters? You are met with accident. You can't do that. Now imagine what is the intelligence is required. Yes, their intelligence is required. Google should understand how I am keep on giving that 500 meters, turning 500 meters, something wrong. So immediately it should call the nearest police station or nearest ambulances, something which really required the people to, should able to get attention, should save you. So what is the here? Intelligence, intelligence in the system. That's what people are using it. Understand? So that's why the next coming generation already using. Still a lot of research is there. And I'm telling, it's all maths. Really mathematics professor, teachers, all are, they have a very big scope with this new concept, which is called as a machine learning. Understand? So how the mission, see, same way now in my lab also, my director asks, why this much power is there? Why can't you control it? So now you tell me, what is the required? My requirement is shut off the unused freezers automatically. Find the system to be intelligent. So my system, no human intent automatically. The computer should think it of there's something wrong. I'll tell you how it is possible. Like if you see this, small, sorry. So if you see this is the temperature. A small example I taken. Now you can imagine. Oh, sorry. One point I want to tell you, sir. Only 1 minute. Sir, what you understand by straight line? This is what I missed in my school. What I understand in my life. I want to tell you. You people also continue. Tell me, what is the straight line tells? If any teacher has told to you. If you ask a teacher, what is the straight line tells? What he says? What straight line tells? Nothing. No, wrong. Anyone can tell? What straight line tells in my vision? Yes. Here, based on my current, it tells what is the, come on, temperature. See, very interesting point. Why straight, what the straight line tells is here in this scenario. If I know what is my current, I'm automatically predict, estimate what is the temperature. Who is doing? These are math equation. These are mathematical functions. Mathematical function output is giving. So I always tell this generation student should aware this type of things. I think these are the more important for us to make you more clear how this is okay. If you know well, otherwise make you people more practical approach. This type of environment should be provided. Take these examples. Instead of asking to draw a straight line, making them to give example of this type, this will be more useful for the people to learn more efficient way. That's what I can. Thank you. I want to put you this word. Now you see here, sir, what you understand here if you see that data. Very interesting. If you reduce the temperature, the power consumption, sorry, increase the temperature, power consumption is reducing. Understand? The usage of, if you see this is the data. Now, if you see this data, you'll find how it is been, okay? The temperature, relationship between temperature and, okay, and power consumption. So now, here I want to using this data, I want to learn. Sorry, I want to make mission to learn. Mission to tell. What is the mission learning? I think most of the people knows because a lot of journals everywhere is available. But as of simple words, prediction, very simple. Something is available, use that and predict. That's all. For the unknown data. Understand? You can predict it. Today, we are all getting a message as more efficient. Rain is going to come within 1 hour. How? This is the one. Today, we have a government of India has provided a lot of money for this. Pune, we have very good weather report centers, very good high-end computing systems. These are all chodo. You have a hardware, but what is the again? Algorithm, mass, and always stay great. Without that, nothing is possible. Okay. You have a high-end missions, high-end systems, but without software, without process, algorithms, it never be possible. Anyway, thank you. So here, if you want to see this one, how the temperature and power consumption, what is our people can predict? Very simple. Suddenly see, I'll tell you a small example. Now in my system, I made my machine learning. I made it if the system is on and power is increasing, okay, beyond certain limits or out of the way box, then immediately it sends an alert as something wrong. You go and check. Okay, something is going wrong there. And immediately that person and go, really I'm telling, sometimes the deep freezer's doors are not properly shut off. What is it? If you don't put doors, it doesn't shut off properly, what happens? Air goes, room temperature air goes inside, which is minus 80 degrees and this is 25 degrees. And keep on, the compressor is on. Once keep on compressor is on, I need not talk again. So wastage of efficiency. Not only that, the samples get damaged. So to avoid this type of conditions, the machine learning is very, very useful for me. So for this, we are going to talk, or I'm going to how. So lower temperature required AC to work harder and longer, of course, that you can understand. But again here, we are going to have both temperature and power consumptions are variables. See, very interesting. So suitable for very simple foundation of your machine learning, because linear relationships, we call as linear regression. Lot of applications are there. Okay, sir? So you can imagine, you can learn this linear regression. Start from linear regression. You have a lot of machine learning algorithms are coming. You can think it of, develop something new, because a lot of research scope is there in this algorithms. Okay, so now back to here. So we are basically, I want to introduce how I started from manual observation to automation. What is the advantage of automation? My power consumption reduced. My samples are not become damaged. Now I want to go for next generation, which I am talking about today's present technology, which people are very happy and using in our systems, which we call it as a linear, what you call it? Machine learning. Okay, again, this is a very simple approach. Yes, sir. Now you see there, sir, I have taken data. That data you see, yes, 18 degrees, 12 power. Okay, now you tell me, if I draw straight line, what is the happens? I can draw a straight line or I can draw a curve. But that is you think it of? Anyone can think it of? What is the new box here? Very simple. I don't want to draw a line for these points. Okay, sir. I want to draw a line. If you see this is very interesting. This is what linear regression. What are these? These are all my points, which are real points. Okay. Now I've taken 10, 11, something, 10, 14, some random points. My data set. Don't think it of how this data has come. So based on this data, Anyone thinking of what you required? Use these data points. Very interesting. Now, create a linear relationship, straight line. This is more important for us. Understand? Which fits for this line. What is that one? Which fits for this point. Which fits for this one. Now you tell me, what is this point, sir? This is a real point. Now, if I take this x value, the corresponding y value is there. Understand? But this point is not interested. This is the point which are called estimated values. Please remember. This is the actual value. This is estimated value. Please remember. Actual value, estimated value. Actual stars are actual values. If I draw straight line on this line, this value, y values are estimated values. Again. So now you tell me, what is our interesting scope here? How to find estimated values, okay, and draw a line. That line will predict for new values. That's all. Nothing is there. If I draw a line for this existing line, what is the, tell me, sir, what is the problem? It gives only these type of lines. It cannot predict beyond this box. Please understand. It cannot predict beyond this box. This is an old technology. But today, using these values, you draw a new line which is not composed of these points. Of course, you can compose, but you can create a new line which is making to close to this. How it is possible, sir? Very simple. I think you all know well, mathematics teachers. Again, statistics comes. Understand? Statistician is always do these jobs. Very simple. You find the distance between these 2 points. This is the y1. Assume this is a y cap or something h of theta, some notations are there. You find this distance. You find the distance between these two. You find the distance between these two. You find the distance between these two. You find like that. Whatever data you have for that, you find the distances and come on. You find some of those distances with square of some of the distances, okay, which we call, I think you know all mass, sigma summation of all those errors, we are going to call mean square errors. Understand what it is called, sir? Mean square errors. So now here we have, you're going to have the mean square errors. 1 minute. One minute, sir. I'm going to have. Yeah. Okay. This is the one. 1 minute. Yeah. Now you can see. So I'm explaining about, this is the one which you are taken. This is the original data. This is the temperature data points. This is the kilowatt hours, which is the one. So now my role is how to find this best fit line. Understand? So this is what the linear regression is a example. So now basically you can all study that how to find the linear regressions lines. For that, we are going to change. I think imagine, now you think it of Where is the question comes? How to find this line? Very simple. What is not there for us? You think it of what is not there. Here we don't have M and C values. Very important, sir. Previously, I got M and C values for my X1, X2. Now I don't have my M and C values. So I should find M and C values of for my new lines. Find this set of lines. Again, lines is coming here. Set of lines and make you such a way the minimized error will be generated. That's all. So you have to find the minimized square RMS value, minimized square errors, and find that values and take out that value, use that value of M and C, and then you are going to get a beautiful estimated line which fits your data, and that will give you estimated values. Based on this estimated values, you can take applications, different applications. Okay, you can enjoy with machine learning. So this, okay, sir, one small thing I want to tell you, and I'll stop you because my time is over. So here, linear regression is simply nothing but having a set of data points, taking the set of data points, finding the suitable line which fits into that set of points, and by taking the mean square errors with minimized values. Okay, so we are calculating M and C values with the help of actually decent curves will come actually. If you take a curve nature, it will be calculated. So that we call cost function. Very important for us is we are going to take the cost function. That cost function minimum value will be taken. That cost function contains what, sir? Parameters M and C. M slope and constant, your interceptor. So find the cost function. Here little bit we use partial derivatives also. And we have the equations also available on the net. You can see that. So how it actually I missed that slide. Okay. Sorry for that. Anyhow, thank you, sir. Thank you all. Anyone can ask? I'll stop.
Thank you, sir. I request from the participants' end, if you're having any queries, kindly post a message in the chat box, or else you can unmute yourself and ask your queries to sir.
I think they can ask if anybody is there. Chart. Because we are not regular lecturers, and this, okay, this is online. Okay, where is the chart? Okay.
Yes, any queries?
Thank you, Narendra. Nice session is given. Yeah, I request all teachers, please take the mathematical, this regression algorithms, and okay. Okay, ma. Thank you.
Okay,
Sir?
sir.
Vasundhara, ma'am?
Sir, this is Vidya Bhargavi, sir.
Oh, okay. Thank you.
Sir, I'm working for Stanley Engineering College.
Oh, nice.
Yeah. Sir, actually, did you teach in IET, sir?
Yes.
Huh?
Same person.
Yeah.
You remembered me, huh?
Yeah, you are my teacher, sir.
Oh,
Yeah.
thank you. Thank you. You came for project or?
No, I did my MTech there, sir. ALCCS, evening
Oh,
course.
you are ALCC student. Okay,
Yeah,
nice.
exactly.
Oh, I taught for you computer graphics and networks.
Yeah, exactly, sir.
Thank you, Amma. Thank you. Just
Yeah,
now
thank
I
you.
retired actually.
Oh,
31st. Okay. You see, my passion is teaching. So I used to
okay,
go
okay.
and I'm very blessed as a teacher because of Usmania University. Really
Expertise
great.
in real world examples.
Okay.
So that's the reason how I came to know. But anyway, whatever knowledge I have, I'm sharing like this, conducting
Right.
seminars.
Thank you so much, sir.
Thank you, Amma. Thank you all. Shall I leave?
Yeah, you can.
Yeah.
Anusha, you can continue.
Radhakrishna, sir. Thank you so much, sir.
Ah.
This is Vasundhara.
Oh, Vasundhara. Okay. How you feel, ma'am? Are you happy?
Yes, sir.
Good. Thank you. I suppose.
Sir, I would like to take a moment and extend my heartfelt gratitude to you for sharing such an insightful and timely talk on sustainable energy in IT infrastructures.
Yes, yes.
Your expertise in real world examples from CSIR-CCMB gave us a glimpse of
Yes.
what's possible when technological advancement is paired with environmental responsibility.
Yes.
Thank you for taking the time to be with us today, for
Yeah.
sharing your knowledge, and for inspiring us to be more mindful and responsible in how we build our digital future.
Thank you.
Thank you very much, sir.
Right. Thank you.
Vasunthara, shall we take 5 minutes break and continue the next session?
We'll give 10 to 15 minutes break and we will start at 3:25 like that. Abhilash will join at 3:25.
Okay.